Hello guys, I'm going to show you guys how to solve the shortest distance after row addition queries LeetCode problem. This is the daily LeetCode problem for November 27th. So what we have here is we have a directed graph that's going to go in order of 0 to n. And what they're going to do is they're going to give us a list of additional edges. And every time an additional edge is added, it's going to ask the shortest path from 0 to 4. When you hear shortest path, you're always going to use a BFS. We're going to do a bit of setup. So to start, we're going to build an adjacency list. In Python, we do have some tricks to be able to do that. We do I plus 1, I in range of n. This is going to create the basic adjacency graph where it's going to be 0 points to 1, 1 points to 2, and so on, all the way to n. Once we have that, I'm going to use a result array to return. We're going to go ahead and declare that. And for here, we're going to do the BFS. And to start, we have to iterate over the queries. So we're going to do for source, destination, in queries. First, we're going to do is add that into edge. So adjacency source dot append destination. And now we need to declare some of the structures that are needed for the subsequent BFS. So first we need the queue itself. We can do queue dot append. Starting off, we're going to do 0, 0, which is going to be index, comma 1. We're also going to need a set. Set is just a hash map. Doesn't allow duplicates, and yeah, it makes it a lot easier for us. So we can do visited, and then we can do visited dot add 0. Okay, so now we can do the actual BFS. And before I got too far, I do want to kind of point out the complexities here. We're going to call this for loop big O of Q so far. Now we can do the actual BFS. So for the BFS, we're going to start off with while Q as a variable. We will then pop left. We're going to do index length equals Q dot pop left. If you're not familiar, this pop left is a function as part of the DQ class. Very useful in LeetCode problems. We are then going to add this, or no, we have it to the adjacency list. So then we'll check if we're at the end. So if index equals n minus 1, we know we've reached the end. We can then do res dot append length, and we can actually break. We've reached the end for this BFS, so we can iterate to the next query here. But if it's not the end, we can then do for, I'm going to call it node in the adjacency for the given index. And we can check it. Node is not in visited. We can do that. We can do dot append node length plus 1 and add it to visited. Cool. With this, we should be up and running. Let's give it a run, see if I made any mistakes or if we're good to go first try. We are. We can go ahead and submit. And there we go. And we have a pretty optimal solution. Thanks.